This video is about review for quadrilaterals and circles. Please break up your paper so that you can fit in the 5 examples shown. For this question, they're asking you to find x, and they've given you this trapezoid and this information. So let's start by labeling it. Tx is 3x plus 5, xa is 8, px is 5x minus 1, and xr is 12. Now, first I'm going to take a look at this picture. It's an isosceles trapezoid. That means that the base angles are congruent. Base angles are congruent. It means that the legs are congruent. And it means that the diagonals are congruent. Diagonals are congruent. And this is actually the property that we're going to use to set up this equation. That means that this entire diagonal is equal to this entire diagonal, or, so 3x plus 5 plus 8, that's one diagonal, should be equal to 5x minus 1 plus 12. And if I combine like terms, that's 3x plus 13 equals 5x plus 10. So I'm going to go ahead and subtract 5x from both sides to get negative 2x plus 13 equals 10. I'm going to subtract 13 from both sides to get negative 2x equals negative 3. Divide by negative 2, so x equals 3 halves, or 1.5. For example 2, this is a word problem, and here's what they're telling us. You have a parallelogram named FGHI, and it has two diagonals, IG and FH. They intersect at point M, and they want to know what can we prove. So let's start by drawing the parallelogram. The definition of parallelogram is that the opposite sides are parallel, so that's important. And it's parallelogram FGHI. It's got two diagonals, so IG and FH, and they intersect at point M, and they want to know what can we prove. Now, some of the other properties we know about parallelograms are that opposite sides are congruent, and I also know that opposite angles are congruent. And I know that the diagonals bisect each other. So we're just going to write down all the things that we know. I could prove that triangle FMI is congruent to triangle HMG. That's this triangle and this triangle by side, side, side. I could prove that these big triangles, so this one right here, triangle FIG is congruent to triangle HIG. So I can prove that this triangle is congruent to this triangle by side, angle, side. And then there are little things I can prove too, like I can say that angle F is congruent to angle H, and that's just by property of parallelogram. I could say that angle 1 is congruent to angle 2. Those are vertical angles. A parallelogram has a lot of triangles in it that could be proved congruent, along with all these other sides and angles. So this should be a long list. See if you can come up with 2 more. For example 3, they say for the quadrilateral shown, what is the measure of angle A plus the measure of angle C? Well, first I see that this is a quadrilateral, and they're talking about angles here. So I know the angles in a quadrilateral add up to 360 degrees. That means 93 plus angle C plus 35 plus angle A should equal 360. Now, 93 plus 35, let's go ahead and combine like terms. That's 128. So angle C plus angle A plus 128 equals 360. If you subtract 128 from both sides, let's go ahead and subtract. I'm going to borrow from here. 10 minus 8 is 2, 5 minus 2 is 3. That's 232 degrees. So angle C plus angle A is 232 degrees, which is precisely what they were asking for. So this is actually our answer. Example 4 is also a parallelogram problem. I know that because the opposite sides are parallel. So in here they're asking us what is x. Now here this is an angle and this is another angle. So to find x, I have to know what's the relationship between the angles in a parallelogram. These two angles are not opposite. If they were opposite, I could say they were congruent. This angle is congruent to this one over here, and this angle B is congruent to angle D. But what's the relationship between two adjacent angles, two angles that are right there on the same side of two parallel lines? Those are same side interior angles, and same side interior angles are supplementary. That means the measure of angle A plus the measure of angle B is 180 degrees, or x plus 30 plus x minus 12 equals 180. So combining like terms, I get 2x plus 18 equals 180. I'm going to subtract 18 from both sides, and that gives us 162. When I divide by 2, x equals 81 degrees. Last example is a word problem. Let's read it and underline the important words. So the diameter of a circle is 8 inches. So I'm going to go ahead and draw a circle, and its diameter is 8 inches. Okay? Point P is in the same plane. So I'm going to go ahead and draw a plane. Here's a big plane. And point P is somewhere in this plane, and it's 4 inches from the center of the original circle. So this is the center. If it's 4 inches, that would be half of the diameter or the radius. So that means point P, no matter where it is, it's somewhere on this circle. So when they ask, what can we deduce? Well, by simply drawing the picture, I can deduce that point P is on the edge of the circle. And I know that simply because of what I know about diameters and radii. And that's it.